In this episode, we build a practical mental model for validating whether a service is behaving like a well-designed REST API, and we do it by understanding three common clients you will hear about in operations: curl, get, and postman. Representational state transfer, REST, is a style for designing services that expose resources and application programming interface. API is the boundary where one piece of software asks another for information or action. When something breaks, operators do not guess first, because guessing creates extra noise and can accidentally make the problem worse. They validate what the service is actually doing, what the client is actually sending, and what is happening in between. The goal here is not to turn you into a command expert, but to teach you how to think clearly about requests, responses, and evidence so you can confirm behavior, isolate failure points, and communicate what you found without hand-waving. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful starting point is to treat API validation like checking a conversation for misunderstandings rather than treating it like hacking at a locked door. Every request has an address, a method, headers, and sometimes a body, and every response has a status code, headers, and usually a body. If the server is the one being questioned, your job is to ask the same question consistently and observe the answer. That means you want tools that show you what is being sent and received, not tools that hide details behind friendly screens. You also want tools that can repeat a request without silently changing it, because repeatability is how you confirm whether a behavior is stable or random. When someone says they validated an API, what they really mean is they produced a small set of reliable observations that match the expected contract for the service. That contract includes format, authentication, error handling, and the difference between retrieving data versus changing data. Curl is best thought of as a lightweight, direct way to make a request and see exactly what comes back, with minimal extra behavior. In operational work, curl is popular because it is small, widely available, and tends to make the network conversation visible instead of magical. Even if you never type anything, you can understand what curl is doing by focusing on what it can reveal: the raw response body, key headers, timing, and whether the server is reachable at all. It is especially useful when you need a quick reality check, such as confirming that a service endpoint is responding or confirming that a response is returning data in the expected format like JavaScript Object Notation, JSON. Because it is so direct, curl also makes it easier to notice when the client is missing something the server requires, like an authentication token or a required header. That visibility is often the difference between a fast fix and a long argument. Git has a different personality, and it helps to understand what it is trying to be good at. Historically, Git is associated with retrieving content and saving it. So many people think of it as a download tool rather than an API testing tool. In operations, though, validation is not always about complex requests. Sometimes it is about confirming that a service is reachable and returning what it claims to return. Git can be useful when you want to check whether a resource is available, whether redirects are happening, whether content is being served over the expected protocol, and whether the response is stable across repeated retrievals. If a service claims a file is published at a certain address, Git fits the mental model of retrieving that resource and verifying it is the correct content. For beginner thinking, you can place Git in the category of retrieval validation, where the primary question is whether you can fetch something reliably and whether the server is responding consistently. It is not the only tool for that job, but it can be a simple one. Postman is different from curl and get because it is built around exploration, organization, and repeatable collections of requests that humans can run and share. You can think of it as a workbench where you craft a request, run it, inspect the response, adjust details, and then save the working version so you can rerun it later. In operational scenarios, Postman becomes valuable when you need to validate a workflow that takes multiple steps, such as authenticate, retrieve a resource, update it, and then confirm the update. It is also helpful when you want to see how different inputs change the response, because it makes it easy to swap values while keeping the rest of the request consistent. Another advantage is that it can make the structure of the request very explicit, which helps beginners learn what headers and body fields actually look like. The risk, if you are not careful, is that a visual tool can encourage random tweaking, so you still need the discipline of changing one variable at a time and documenting what changed. No matter which tool you use, validation starts with knowing what success should look like before you start looking for failure. For example, if a service is supposed to return a list of devices, you should expect a success status code and a response body that is structured, consistent, and parsable. If the service is supposed to require authentication, you should expect an unauthenticated request to fail in a predictable way and an authenticated request to succeed. If the service is supposed to support updates, you should expect the read-after-write behavior to show the change, even if there is a short delay. Beginners sometimes validate the wrong thing by only checking that something responded, but a response that is incorrect is still a failure. Validation means confirming not only that the service is reachable, but that the content, format, and rules match the intended contract. That is why operators look at both the status code and the body, and they do not treat either one as enough by itself. A major part of validating REST API behavior is learning to pay attention to headers, because headers carry the rules of the conversation. Headers can indicate the type of content being sent and received, how authentication is presented, how caching works, and whether the server is asking the client to do something different next. For a beginner, the easiest way to think about headers is to treat them as metadata that tells you how to interpret the body and how the server wants you to behave. If a server returns a body that looks like JSON but labels it as something else, that mismatch is a clue to a configuration problem. If a server responds with an authentication challenge, the headers often explain what kind of authentication it expects. Tools differ in how clearly they show headers, and that is one reason curl is often used when people want to see the raw conversation. The point is not to memorize every header, but to recognize that headers are part of the evidence. Another part of validation is paying attention to what method is being used and whether the response matches what that method implies. A retrieval request should not create new records, and an update request should not silently create duplicates unless the design explicitly says it can. When beginners test an API, they sometimes accidentally trigger changes because they are not thinking about the side effects of a request. An operator mindset is careful about when you are reading versus when you are changing, and it includes verification after changes, not just the act itself. Postman can help here because it can organize requests into sequences, which makes it easier to remember to do a read, then an action, then another read to confirm. Curl can help because it makes a single request very explicit and repeatable, which is good for confirming a specific behavior. Wget typically fits the read side of the world, where the validation is about retrieval and content, not about complex modification flows. When things do not work, it is tempting to immediately blame the service, but good validation also tests the network path and the client assumptions. A request can fail because the address is wrong, because the network is blocked, because a proxy is interfering, or because name resolution is pointing to the wrong destination. It can fail because the client is missing a required header or sending a body in the wrong structure. It can fail because authentication is expired or because the server is refusing a request based on permission. Tools can help you distinguish these categories by what they reveal about the failure, such as whether there was no response at all versus a response that clearly denies access. When you can tell the difference between cannot reach and reached but rejected, you move faster and you communicate more clearly. That is one reason operators like tools that show timing, connection details, and response metadata, because it keeps you grounded in observable facts. Security and trust also matter in validation, because modern services often require encrypted connections, and failures there can look confusing to beginners. Transport layer security, TLS, is what protects the connection between client and server, and it relies on certificates to prove identity and enable encryption. If there is a certificate problem, the client may refuse the connection, or it may warn that the identity cannot be verified. In operational validation, that kind of failure is not just a technical nuisance. It is a signal that something is misconfigured or that a security control is blocking the connection. A beginner-friendly way to think about it is that the service might be online, but the secure handshake fails, so the conversation never truly starts. Different tools present these failures differently, with some showing more detail about what went wrong. The skill you want is to recognize that ATLS error is a different class of problem than a permission denial or a missing resource, and it should be investigated along its own path. One of the most practical operator habits is to reduce a problem to the smallest reproducible request that still demonstrates the issue. If a complex workflow fails, you do not keep rerunning the whole thing blindly. You isolate which call in the chain is failing and then validate that call by itself. This is where Postman shines, because you can focus on a single request in a collection and run it repeatedly while adjusting only the one detail you are testing. It is also where curl can shine, because you can repeat the same request in a minimal way and compare results across attempts, which helps you detect intermittent problems. If the failure is about retrieval of a resource, Git can validate whether the resource is consistently accessible or whether redirects and timeouts are involved. The key idea is that validation is an experiment, and good experiments change one variable at a time. That discipline is what turns a confusing failure into a clear explanation. Another operator-level skill is recognizing the difference between a functional response and a correct response. A service might return a success code but still provide unexpected content, missing fields, or values that do not match what the system claims is true. That kind of mismatch is especially common when there are multiple environments, caching layers, or delayed consistency, where a change takes time to appear in all places. Validation tools help you compare what you expected with what you actually received, and they help you capture the exact evidence so you can show the mismatch to others. Postman can be helpful because it makes it easy to rerun the request and visually inspect fields across runs. Curl can be helpful because it shows raw output and headers, which makes it easier to notice if you are hitting a different host than you think. The overall lesson is that correct behavior includes content and timing, not just the existence of any response. It is also important to validate error behavior intentionally, because a well-designed API fails in a predictable and informative way. Beginners often treat errors as random or unhelpful, but many errors contain valuable clues about what the server expects. A permission failure tells you authentication and authorization are involved. A missing resource tells you the identifier or path may be wrong, and a request format failure tells you the body or headers are not being interpreted correctly. Using tools effectively means you do not stop at the first sign of failure. You read the response body and the headers and interpret what they say about the contract. Postman can help you see structured error responses clearly, especially if they are in JSON, and it can help you compare error responses to success responses side by side. Curl can help you see whether the server is returning different errors depending on small changes in the request. When you treat error behavior as part of the design, you become much better at diagnosing problems quickly. Finally, a big part of effective validation is communication, because the value of your work increases when others can understand and reproduce what you observed. An operator does not say it is broken and move on. They say what request was attempted, what response was received, and what expectation was violated. Tools like Postman can help because they encourage saving and sharing the exact request structure, while curl encourages capturing the raw response details that show what happened on the wire. Even without focusing on any specific implementation, you can practice the habit of writing down the essential facts: the method, the address, whether authentication was used, what status code came back, and what key detail in the response proved the behavior. That kind of reporting makes it easier for someone else to confirm the issue and fix it. It also keeps you honest, because it anchors your conclusion to evidence rather than assumptions. When you zoom out, curl, get, and Postman are not competing magic wands. They are different lenses on the same network conversation. Curl tends to be the sharp, minimal lens for seeing the raw exchange and repeating it cleanly, which is great for confirming specific behaviors and capturing precise evidence. Git tends to be a practical retrieval lens that can validate availability, stability, and content delivery for resources you fetch, which often matters in operational systems that publish artifacts and files. Postman tends to be the organized workbench lens for exploring, iterating, and sharing multi-step request sequences, which is valuable when validation involves workflows rather than a single call. If you remember that validation is about observable facts, repeatable requests, and clear reporting, you will choose the tool that best fits the question you are trying to answer. That is the operator mindset. Pick the smallest, clearest way to prove what the system is actually doing. Then use that proof to fix the right problem.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.